Okay, welcome now to a demonstration I'm calling the rolling motion. I've done a demo before on this where I've compared the rolling motion of different shapes. It was a sphere, solid sphere, hollow sphere versus a cylinder versus a hollow cylinder versus a solid cylinder, and I've shown you which one wins and why, and it had to do with the moment of inertia of the shape. Now I'm going to be comparing three bottles, one full of water, one half full of water, and one empty, but they're all going to be cylindrical shape. So it's going to be cylinder. So one is going to be basically empty. One is going to be half full of water, like this kind of. And then the other one is going to be, this, let's call this half. And then the other one is going to be empty. And then I'm going to roll them down the table. And I want to ask the question, which one will win the race and why? I want to make a hypothesis. So I'll first race this is the full one. Okay, so I'll first race the full one with the empty one, right? And then ask the question, which one do I think should win? Well, based on moment of inertia, the full one, the distribution of the mass is distributed all throughout the object, right? So the distribution of the mass, so the moment of inertia is equal to 1/2 mr squared. The empty one, the moment of inertia, is mr squared. So even though the full one is heavier, and some might say it has more inertia, well, it's harder to make it go down the incline. It's not really which one is heavier that matters, it's the distribution of the weight. The distribution of the weight of this is all distributed throughout the object, so it is actually easier to rotate that object. The distribution of the empty one is all on the outside of the bottle, and it's harder to rotate it. So I predict that the full water will win. So when the full water one is here, the empty one is going to be probably roughly there. So when we run the experiment, then I'll race the full one with the one that's half empty, and then let's make a hypothesis. Now, some might say because the full beat the empty, the full is probably going to beat the half. But that one is not that easy. It's not as easy as that. Because if you fill the half bottle one with just about enough water where the water is kind of collected on the bottom half, and if the water does not rotate with the bottle, it kind of just sits on the bottom, it kind of acts more like a sliding object without friction. The bottle itself rotates, but the water kind of just slushes on the bottom, and it just sort of slides, and it pushes the bottle ahead. The half-empty one might actually beat the full one. It depends, of course, on the bottles, if they're made the same. It depends on the incline that they're sitting on, the friction on the incline, all of those other sources of error. But if you have just enough right amount of water where it's just sort of sitting, the half-empty one might actually beat. So it's going to probably be a close race, but I probably suspect the half-empty one will be somewhere here, and the full one is probably going to be somewhere there. So even though you would think that the full one should beat here because the distribution of the weight is all throughout the object, here it's more acting like a sliding object. So let's run the experiment and let's see what happens. Here you see I've got the full one on this hand, and then I've got the empty one here. Of course, it depends if there's some dents on the bottles and stuff versus this bottle. So depending on the shape of the bottles, that will also affect it. And then there's creases here that will also affect it. But it's not a perfect demo, but you can kind of see the idea. So I have the bottle here full on this side, and I've got the empty one on this side. We'll run the race a couple times. Let's see who wins. And I got to make sure that I start them both at the initial velocity of 0 and get them going at the same time. Okay, so let's get that started here. This one kind of takes a while to get going. I can give this one, the empty one, a bit of a push. You can see it's way behind. The distribution of the weight is all on the outside, and so it's harder to make that rotate. See, let's run that again. Yeah, the full one just wants to kill the empty one, right? So we can now exchange them. Exchange places. I'll give the empty one a bit of a push. Yeah. So, do that again. Yeah, it's not even close. So you can see a good idea comparing two shapes that are the same, one full, one empty. Now let's do the half full. Okay, so this one is the half full. I kind of did it, I filled it up kind of to this level, right? And then when I tilt it, I kind of want to make it where it probably fills up to the cap here. And then when this thing rotates like this, when this thing rotates, the water just sort of sits there instead of rotating with the bottle. It just sort of sits there and it glides, it slides down. And we might see that this one will win. Okay? So let's give the same initial conditions. Okay, that one was close. The full one still won. But it could have been because of the initial conditions too. Okay, this one, the half empty bottle one, the half empty bottle one. So you got to really make sure, give this the same initial conditions. The best way to do this would be probably to time them separately, randomly. Do it like 100 times. You know, keep doing them, you know, because no matter how good of a job you do in one single race, your initial conditions is likely going to be different. So if you were doing a good experiment with this, maybe in a high school setting or college setting, just randomly time these and then see if you get a difference. And you might see that this one, if it's filled correctly, might actually win. Okay? Okay, this one, the half empty one, lost. Okay, do it one more time. Okay, this one was slightly ahead. Now let's exchange places. Okay. Okay, this one, the half-empty bottle won. That was a little bit ahead of the other one. I'll do it again. So it really depends how you let go of them. Really, really sensitive to that too. Okay? Okay, so you can see a good demonstration here of the concept of moment of inertia, taking three different things of the same shape, but at the same time playing with the amount of water to see if you can create a situation where it just glides, and then compare them. So you can make a really good experiment out of this. And even try different amounts of a half full of water. Maybe 40% full of water, 30% full of water, 60%, 70%. Try different ones. See if you can create a situation where the water just glides, and then compare the runs, and then see which one wins. Okay? Thank you very much.